All through your course you will have looked at loads of studies and investigations. Now you need to be aware in each case of the type of method that was used and be able to evaluate it, as well as the strengths and the weaknesses of each study. Now we're going to recap on quantitative and qualitative research methods, research and implementation, and data analysis. Quantitative data mainly contains numbers and so can be graphed and analysed statistically. Qualitative data is not numerical. Case studies and interviews generally produce qualitative data. An experiment is a way of doing research in a controlled way. Now, experimenters try to control all the variables except one key variable, the independent variable. But they may be able to measure the effect of changing the independent variable by measuring how the dependent variable changes. Psychologists use laboratory experiments, field experiments, and natural experiments. Now, laboratory experiments are carried out in an artificial setting. Milgram's and Ash's studies were lab experiments. So, the advantages of laboratory experiments are that we can control variables, also replicate the experiment to give a high reliability, and lastly, so that we can see if the independent variable causes a change in dependent variables. The disadvantages are that they are low on ecological validity, and also that participants may respond to demand characteristics or how they think they should act, and the experiments may be unethical because they will involve deception. Think of Milgram's study. Imagine how people in Ash's study might have felt stupid when debriefed. Field experiments are outside the lab in a natural setting, such as a street or on a train. Now, you can control independent variables, you can see what effect it has on dependent variables, so we may be able to establish cause and effect. These experiments have high ecological validity, and most importantly, participants don't respond to demand characteristics, as they don't know they're in a study. But the disadvantages are that you can't control variables. Also, they can be seen as unethical because participants can't give informed consent and sometimes can't even be debriefed. Natural experiments measure variables that aren't manipulated by the experimenter, they occur naturally. So, for example, psychologists could study the learning achievement of boys in single-sex and co-ed schools. Advantages of natural experiments is that it's not set up. Now, this is because the experimenter is not manipulating any variables. But the disadvantage is that the experimenter can't allocate participants to different conditions, so there may be confounding variables also affecting the results. It could also be considered unethical if children are being studied. Correlational analysis looks for relationships between two variables. Often, as one variable changes, so does another. But that doesn't necessarily mean that one causes the other. There is a correlation between left arm length and right arm length in people, but the length of your left arm doesn't cause the length of your right arm. An advantage of correlational analysis is that if there is no correlation between variables, then we can conclude that one doesn't cause the other. It may be unethical to manipulate variables. In a study into the effect of certain nutrients on reducing depression, the experiment had to be stopped as the effect of the nutrients was so good, it was unethical to deprive the control group of the nutrients in question. The disadvantages of this type of research is that just because there is a correlation, we can't say for certain that one causes the other. Correlation doesn't necessarily mean cause, although people sometimes infer that there is a causal relationship. Naturalistic observations are where people are observed but the observer doesn't interfere. Now, these often act as starting points, as they provide anecdotal evidence that may then be tested later by controlled investigations or experiments. A huge advantage of this type of research is that it has high ecological validity, as people are in a natural situation. Also, there are no demand characteristics, because people don't know they're being watched. But, surprise to surprise, back to the ethics again. The disadvantage is that it can be unethical, because if the researcher observes people in a public place, they are invading their privacy. But on the other hand, if people are in a public place, they must expect to be seen. Questionnaires can be used to collect information from a large number of people. It's relatively cheap and quicker than interviewing lots of people. Questionnaires have the advantage of being written or verbal, so they're quite flexible. Some surveys are carried out by phone, but only specific questions are asked. However, there are disadvantages. People may not answer truthfully. Not everyone responds, and perhaps those that do respond may not be representative. The questions may not be well designed, and people may not understand them. Interviews are really verbal face-to-face questionnaires. Structured interviews ask everyone the same question, whereas unstructured interviews use a set of topics but allow each conversation to develop individually. Unstructured interviews provide richer data than structured interviews or questionnaires, but people can show social desirability bias and not be truthful. They're also time-consuming and produce data that is difficult to deal with. For both questionnaires and interviews, much of the information gathered will be confidential, so this raises ethical issues. Also, for both, it's good practice to draft the questions and then carry out a pilot study with a small sample. This will help to see if there are any problems with questionnaires. For example, if there are any faults with the questions, or if there is any ambiguity concerning the way the questions are written. It allows the researcher to fine-tune the questionnaire before doing the full survey. So, obviously research is a complicated process, but how do researchers go about doing some research? Well, first of all, they have to state the aim of their investigation. Now, this can be as broad as to study the effect of music on learning. The next stage is to formulate a hypothesis. Now, this could be a prediction that's going to be tested. If statistical analysis is going to be used, they must have an experimental or an alternative hypothesis, as well as a null hypothesis. For example, the experimental hypothesis may predict that there will be a relationship between two variables, such as background music will affect performance in a memory task. Note that this hypothesis does not predict how the background music will affect performance, so it is a non-directional or a two-tailed hypothesis. If the above hypothesis is changed to background music will improve performance in a memory task, it becomes a directional or one-tailed hypothesis. Either way, the null hypothesis states that there will be no relationship between the two variables, so it would be background music will have no statistically significant effect on performance in a memory task. Any difference will be due to chance. The statistical analysis tests the null hypothesis. If it's not supported, then we reject it and accept the experimental or alternative hypothesis. If it is supported, then we reject the experimental hypothesis. Now, that doesn't mean that the experiment hasn't worked, as it's still given us some useful information. The design for each investigation must be such that we can test the hypothesis. In our example, you could have two different groups of people doing the memory test, with or without background music. This is known as an independent measures test. The trouble with this is that people in one group might have better memories than people in another group. This eliminates participant variables, but there are order effects. You have to give a different task with music from that without music, or else the participants will have learnt the task. Then it is difficult to make sure that each task is of equal difficulty. When designing an investigation, you also have to think about the variables. Take our example. If you use the same group of people, you have eliminated people variables, but there may be differences with the task. You might find that people differ from fatigue, and so will not perform as well on the second task. You could then divide them into two groups. One does it with music first, then without music. The other group does it without music and then with. You also need to consider things like time of day, ambient temperature, lighting, and what the participants have eaten. Have they had coffee or drunk alcohol? If you use different groups of people, you can eliminate differences with the tasks, but there will be variation between the groups, however well you try to match them. This is a problem with psychology investigations. You are looking at people and they are all different. The research also needs to think about ethics. Can your participants give informed consent? Does the experiment involve deception? How and when will you debrief them? Are the participants under 16? In which case, can you ask their parents for consent? Will they suffer any psychological harm? In our example, you could use students over 16 and ask for their consent. You don't need to deceive them here. The research also needs to make sure that your investigation is valid. Is it measuring what you say it is measuring? Is your memory task suitable? Is it reliable? It has external reliability if you or someone else can do the experiment again and get the same sort of results. So experiments should be repeatable. So how do we make sure that questionnaires are answered truthfully? Well, questionnaires are split into two halves, which ask the same questions in slightly different ways in both halves. You can then check if respondents answer the same in each case. If they do, the questionnaire has internal reliability. How do researchers find their sample of participants? Well, to start with, the sample should be representative and reflect the variety of characteristics found in the target group. But how does the researcher find the people? Well, you can ask for volunteers, but are those volunteers likely to be representative? Researchers could advertise in a newspaper, but only people who read that paper have any chance of being involved. Since a lot of research is carried out in universities, students are often used in studies. But are they representative of the whole population or of the target group? What do you think? Random sampling can be used where everyone in the target group has an equal chance of being selected. Now, you can give everyone a number and then draw numbers out of a hat or use a computer to generate random numbers. It is fair, but doesn't guarantee a representative sample. Remember too that people often behave differently when they are being observed. They may try harder when performing a task if they're interested and like the attention they are getting. If they're not interested, they may not try so hard. Some participants even show demand characteristics to try to please the experimenter. This makes perfect sense. Other participants show social desirability bias. That is, they don't answer truthfully because they want to show themselves in a good light. Of course, it's not just down to the participants. Sometimes the researcher can show bias. This is called experimenter bias. They may not always realise it, but they may be subconsciously only reporting observations that they think are important or that fit their prior knowledge of a situation. Take, for example, Jane Goodall. Now, she studied chimpanzees for many years. She is now an acknowledged world authority on their behaviour. She was a secretary with no formal zoological training and so had no preconceived ideas about their behaviour and as such wasn't biased. Sometimes interviewers may introduce bias by only asking questions that they think are important or interesting. Very careful thought has to be given to the design of naturalistic observations, questionnaires and interviews. When designing naturalistic observations, you need to ask yourself the following questions. How will I collect the qualitative data? So to collect the data, you could make notes, use video and tape record the events so you don't miss anything. If you just took notes, you could miss out on a lot. How will I categorise the behaviour I'm watching? You need a system that is as objective as possible. How will I rate the behaviour? Now, if you use a 0 to 5 scale, you can turn qualitative data into quantitative data, and then you can test them using statistics. How often and how long am I going to observe? When, where, and for how long you sample could give you different results each time. How can I be sure of inter or between observer reliability? If you get two people to observe the same situation using your system, and if they obtain the same data as you, your system is reliable. What do you need to consider when designing a questionnaire? These are the sort of questions you need to be asking yourself. What type of data do I want? Qualitative or quantitative? Open questions are harder to analyse, but give a wider scope for responses. Closed questions narrow the scope, but give quantitative data that is easier to analyse. Are the questions ambiguous? For instance, the words often, regularly, and frequently can mean different things to different people. For example, once a year is regular. Is each question just asking one thing? A double-barreled question like, do you like chocolate and how often do you eat it? Is not a good question because it's asking two things at once. Are the questions leading the participant? Does the question itself suggest an answer? Now, this isn't good. Think back to those leading questions used in eyewitness testimony studies. Are the questions clear? Okay, so is straightforward language used and not jargon? Sometimes researchers may need to have versions in non-English if they want to survey a representative sample of the population. When planning an interview, you need to think about these things. How structured will it be? How easy will it be to analyse the collected data? Will the appearance and behaviour of the interviewer influence the responses of participants? No matter what the design of an investigation, doing a small pilot study first can alert the experimenter to possible problems. In this case, the design can be fine-tuned before the real investigation begins. Now you have carried out an investigation, you need to analyse your data. If your data is qualitative, it's harder to analyse. But it can be converted into quantitative data analysis. For example, you might want to compare crime reporting in a broadsheet to a tabloid newspaper. You could look at each paper and note how many column inches are devoted to crime stories in each. Maybe showing some juicy headlines from a tabloid and the same or similar story as treated by a broadsheet. You may note how many use assumptions, such as racial stereotypes, and note how often these occur. This has now produced numbers, so you could use a statistical test. It may also show trends and patterns more clearly, but you would need to be careful not to be biased when developing the coding system. You've also got to take into account that a lot of detail may be lost by quantifying the data. When you've got quantitative data, make sure you put your data into tables. Give each table a number, such as Table 1.1, and an informative title. This is really useful because you can also graph your data. Bar graphs are used to represent discrete data. There should be gaps between the bars, rather like this one. You could use histograms. These look like bar graphs without the gaps and are for continuous data, so their numbers are on the x-axis. Line graphs can also be used for continuous data and are often preferred for comparing two sets of data. Next, a scattergram or scatter graph. Now, these are used to see if there's any correlation between two variables. If the data is quantitative, you can analyse them using statistics. The simplest type of statistics is descriptive statistics. As the name suggests, these describe patterns found in a data set. They use the term central tendency, which just means the average, mean, or mode. They also show how spread out the data is. This is called the dispersion. To find the three measures of central tendency, you need to do the following. First, the mean. Add all the values and divide by the number in the sample. So, for example, the mean of 3, 4, 6, 7, 9, 10 and 12 is 51 divided by 7, which is 7.29. Secondly, the median. The number in the middle of a data set when the data are put in numerical order. So the median of these numbers, 3, 4, 6, 7, 9, 10 and 12, is 7. Lastly, the mode. Now this is the category that occurs most often in a data set. So here, the mode of 3, 4, 6, 4, 8, 9 and 4 is 4. But sometimes averages can be misleading. If we add up the numbers of children in a large number of families and find the average, we may end up with a number like 2.4. Now, obviously no one has 0.4 of a child. That would be mental. Also, as an example, take wages. If we work out the average salary, it can be misleading in two ways. Firstly, many people think that this means lots of people get that salary. Secondly, the data could be skewed. Many people earn less than £25,000 per year, and just a few earn huge salaries. Now this gives an average salary that in fact many people don't actually achieve, so it's really misleading. Let's look now at measures of dispersion. The range is the difference between the lowest and highest score. The data set 1, 3, 4, 6, 7, 9, 10 and 12 has a range of 12 minus 1, which equals 11. If there was one high number in the data set, such as 35, the range would be 34. Now this could be misleading. To avoid this, we could calculate the interquartile range, or IQR. So let's see how to do this. First, find the median, or Q2, of 1, 2, 3, 4, 6, 7, 9, 10, 11, 12, 35, which is 7. Then, find the lower quartile, or Q1, the value halfway between the median and the lowest score. In this case, it's 3. Then, find the upper quartile, or Q3, the value halfway between median and highest. In this case, it is 11. So the IQR is Q3 minus Q1, which is 11 minus 3, which equals 8. Next, the standard deviation. This is calculated using this formula. Next, correlations. If you're trying to see if there's any correlation between two variables, the first thing to do is to plot the data onto a set of axes as a scattergram. If it looks like this, it shows a positive correlation. That indicates that as one variable increases, the other also increases. The correlation coefficient is the slope of the graph. A perfect positive correlation has a value of 1. If one variable increases by a value x, then the other variable increases by the same value. Not all positive correlations have a correlation coefficient of 1. It may be between 0 and 1, and the nearer to 1 the better the correlation. The nearer to 0, then no correlation. If the scattergram looks like this, then as one variable increases, the other decreases. If the correlation coefficient is -1, that is a perfect negative correlation. But remember that even though a correlation may be shown, it doesn't mean that one variable is causing the other. There may be other factors at work, or the relationship may not be totally direct. It has long been observed that after wars the birth rate for boys goes up. We now know that during a war, the levels of stress hormones, like testosterone, goes up in women, and this can influence whether male or female fetuses are conceived. Also, after a long period of separation during the war, when males and females are reunited, they're likely to have sex more often. This increases the chance of the females conceiving during the earlier part of the menstrual cycle, and this increases the chances of a male fetus being conceived. However, we still don't understand the precise mechanisms at work here, so correlations can be made, but exactly how they work isn't always clear.